The water cycle. Today is the water cycle lesson. Now, before I started this, I probably have already showed you a couple short video clips. Planet Earth, H2O, water, consider this. So let's move right on into the lesson. We do know that the water cycle has been continuously recycling our water since the outgassing of water earlier in its history and some of its coming to the Earth in the form of comets. This constant recirculation at and near the Earth's surface is described by the hydrologic cycle. And so think of the hydrologic cycle as the water cycle. It's why the water that you drink now was probably peed out by a dinosaur, 100 million years ago. Same water. So why are we so concerned about the amount of water and quality of water on Earth? Nice picture here showing what looks like crystal clear water. And the reason why is because fresh water is a limited resource. There's not a lot of it. And if we pollute what we do have, we endanger our own lives and other life on Earth. So to get a clue here as to what I mean by its limited resource, 97% of the Earth is salt water. 3% is fresh water. That's not a lot. Of the fresh water, 68.7% is stuck in the ice caps and glaciers of the Earth. So we don't use that to drink. 30% is underneath the ground in groundwater. And we do use that, wells, you dig a well or drill a well. And that leaves less than 1% as surface water, streams, lakes, rivers. Now of that surface water, 87% is in lakes. Swamps, you don't want to drink that, 11%. Rivers, 2%. So we see that there's really not a lot of fresh water on the Earth. And of that, the groundwater and the surface water is a little over 30% of that 3%. So there's not a lot of fresh water that we can actually access. And of that, because we don't have a lot of it, we really do have to prevent its being polluted by whatever we do. Now, the one nice thing about the water cycle, as far as pollution is concerned, is that every time the water goes through the water cycle, it does a good job of cleaning it out. And at this point, if this is, let's see, I think I will show this video to you after the period ends, or after the video ends. But there's a nice little water cycle movie clip I have here. But you get the idea. We go through all these different parts in the water cycle. The sun heats up the oceans, causes evaporation, and a little bit of transpiration from the plants, from the leaves of plants. And that water vapor goes up into the atmosphere where it eventually rises, expands, and cools, condenses into clouds, eventually forming big enough droplets to fall back to Earth in the form of precipitation. That's stored in the ice and the snow up high, eventually moving downhill in some shape or form. And that runoff part of the water cycle can go right into storage, oceans and lakes, or it can go into the groundwater. And so these are all parts of the water cycle. There's 5 parts here that I'd like to go through. And the first is of course precipitation. We'll start with the P in this. You'll see what I mean in a moment. Rain, snow, ice, all that stuff. Different forms of precipitation. We learned about all this stuff in Unit 6. Runoff. So now that it's rained or snowed down to the Earth, eventually it's going to run off, or it possibly could run off into streams, lakes, rivers, the ocean. Now some of that runoff becomes storage. Storage meaning into the ground or into lakes and oceans. The ground does have a lot of fresh water underneath us, and it's stored in the rock. I know, rocks can't have water, but yes, they can. There's lots of rocks that are porous. We'll learn about that in the next lesson or so. Then that water that's been stored in lakes, oceans, rivers, can evaporate, or plants pull up that moisture from the soil and transpirate through their leaves. You can see transpiration over here. That moisture back up into the sky, and the whole process starts all over again. We have to condense it to make it back to liquid water, though. And that's really the part where it gets cleaned. When you evaporate or transpirate water, just the water vapor goes up into the sky. You don't get a lot of pollution going up with it. It's just it's filtered out in that respect. So there's your water cycle. 5 parts. I like to remember it with the first letters of each of these words. P for precipitation, RO for runoff, S for storage, E for evapotranspiration, and C for condensation. Prosec. Sure beats the letters that I was taught when I was in 9th grade, which was corpse. And that's just a kind of a dark way to think about it. So Prosec I like better. It's actually in a nice order too. All right, the oceans. They're the primary source for most of the water in the water cycle. And remember that the sun is the primary energy source which drives the water cycle. Without the heat from the sun, the energy from the sun, we wouldn't have a water cycle to even occur. So it's the pump that runs everything in the water cycle. Now, since we've already studied precipitation, evaporation, and condensation in the meteorology unit, in this unit, we're going to take a brief moment and focus on the 2 parts of the water cycle we haven't learned about. And that's the storage in the lakes and the oceans and runoff. So we know when it rains to Earth, it usually does one of 2 things. First, it can soak in. It can go right down into that soil, and that becomes groundwater. You can see the well there. It's used to pump out the water. It has to be below the water table to do that. And it soaks into what we call an aquifer. And aquifers are porous rock, and soil too, where the groundwater is stored. And so you might not think of it, but there's rocks that can actually have water inside them, and other rocks which don't. Shale is not a real good rock for an aquifer, but sandstone would be a good rock for an aquifer. So if you drilled a well down to here, you could actually get water. To here, you could get some water. In here, not very good. And here you can see how an aquifer kind of follows the contours of the land. You can see how it's curved upwards a little here as the land curves upward, and it moves down. And this is going to make the water want to flow in certain directions towards low spots, for instance, like towards this stream here. Or if someone's pumping a lot of water from this well, it's going to create lower pressure in this area and draw water towards it. Okay, and that's an unconfined aquifer. That means that there's no rock on both sides of it, above and below, which is confining it. This confining bed is like a waterproof layer of rock, think shale or something like that. And beneath it is a confined aquifer, and that water is much older. To drill that out, you'd have to get a well down into this area. And it's confined on both its bottom and top edges. And then the deeper you go, there's another confined aquifer. This is thousands of years old water, just because it's so much deeper. This is hundreds of years old, and this is just years old. So the deeper you go, the older the water you get. And eventually you go down deep enough, you don't get this water anymore. Okay, now the other thing that can happen is the water can run off. Instead of soaking in to be groundwater, it can literally move off the surface into streams, lakes, and the ocean. Now runoff could be a lot dirtier than the groundwater. The ground tends to filter out a lot of the pollutants by bacteria and fungus, but runoff does not do that. And so in residential areas, you know, where there's lots of houses, people changing their oil, and their car has an oil leak or a gas leak, antifreeze, or fertilizers off farm fields like around here. We have a lot of that, and pesticides. That runs off into streams, eventually making its way into rivers, and it's untreated. So that's really bad for wildlife. Urban runoff, think New York City. Oil, gas, industrial waste, cleaning products, paint, solvents, all this stuff, especially during storms, gets pumped or just gets discharged by gravity right out into larger bodies of water. And you can see that here in New York City, these sewer grates, storm sewer grates, and the water's just rushing right into them during a storm. It doesn't look too clean. And that water is often discharged right out into the New York Harbor without any kind of treatment whatsoever. So storms are, really bad days for cities in terms of water quality. Runoff can also be stored in the form of ice and snow on Earth's surface. And here's a great shot of cloud coming off the top of Gore Mountain. And this snow is stored here until the spring when it becomes runoff. Okay, some factors that affect infiltration and runoff. Well, think about it. If it rains really, really hard, it's raining faster than the ground can absorb it, and so runoff occurs. So rainfall exceeds permeability. That means the ability to soak in when this occurs. And we've all seen this around here with our farmer fields during the heavy rain in the spring. Okay, another factor, steep slopes. The steeper the slope, the faster the water runs off, so it doesn't have a chance to sit there and soak in. So steep slopes equals more runoff. And you can see in this picture on the left, they really need to somehow vegetate this slope to prevent it from collapsing. And on the right-hand side, you can see how they're hydroseeding the hillsides. And that's just a quick way to grow grass on the side of a hill. Around here, we've seen a lot of riprap, large granite boulders, and even screen fences laid down on some of the slopes to keep things from falling. Now, in some countries, terracing improves infiltration and reduces erosion on hillsides. And terracing just, they're flattening off these slopes into sections where they can collect water and then grow stuff. The soil's not running off because most of the soil is on a flat surface, and there's walls where the steep drops are. Okay, third factor, in the wintertime and early spring, frozen ground does not allow infiltration. And up north, where there's lots of permafrost, same thing. Permafrost, permanently frozen. So the water sits on top of this frozen soil underneath. The frozen soil acts like a barrier. Fourth factor, removing vegetation. This is a really good shot showing what happens when people are really dumb about cutting trees down. This is a clear cut on a hill slope. What a stupid idea to cut down all the trees, which the roots are holding the soil together on these hill slopes. Yet it's done. I don't know why people do this. Obviously greed is involved. But what happens is, during a heavy rainstorm, that soil is not being held by the roots anymore, and it just collapses. And so that not only causes potential injury and death to humans and other things, but it really pollutes our streams. Just look at how dirty that stream is in that picture. A lot of that has to do with the fact that there's runoff places upstream from clear cutting. Kills the fish too. Another human-induced factor, paving everything. I mean, if you've ever been to a Walmart or other large box store parking lot during a rainstorm, if things aren't done right, that water just kind of pools up into lakes. But if you stand near one of those storm sewers, there's just like a raging current going down into those storm sewers. And who knows if that stuff's getting treated. I doubt it. 100% runoff, because that pavement is impermeable. It's not letting water through it. And that's it today, guys.